Hello, Algebra 2ers. Today we're going to talk about the average rate of change. You're going to need a notebook, something to write with, maybe a calculator, and your foldable that I gave you in class. Today's learning targets. After today, we're going to be able to describe a rate of change given a table or graph or a given situation or context. So in our introduction, let's think back to Algebra 1 in this problem. In 2008, about 66 million US households had both landline phones and cell phones. We need to think about how we describe the change. Well, in Algebra 1, if you think back, we looked at the change by looking at how the x's changed and how the y's changed. So if we look as our x's changed, from 2008 to 2009, we added 1. As we went from 2009 to 2010, again, we only added 1. And from 2010 to 2011, we added 1. And then as we went over to our y values to look at the change in our y values from our first y value to our second y value, 66 to 61, we would go down 5. From 61 to 56, we go down 5. And from 56 to 61, again, we go down 5. So this is kind of how we describe that change when we're given a table in Algebra 1. So we're going to revisit this after we understand the definition of rate of change. So don't forget this. We'll come back to it. But let's get a definition of rate of change in our notes. So the rate of change can be determined from graphs, tables, and equations themselves. The way we find rate of change can be found by this equation over here, this triangle y over triangle x. So triangle y, we say delta y over delta x, or we say the change in y over the change in x values. So whether you say delta or change in, same thing. This little symbol here though is just the delta symbol. That's saying change in y over change in x's. And this is the formula we will use to find the rate of change in our next couple of examples. So we have 5 steps to calculate the rate of change. The first step I need you to write down is identify the starting point. Okay, understand where we need to start. The second one is identify the ending point of the interval. The ending point, start point, end point, first 2 steps. Step number 3 then is to calculate the rate of change using this delta y over delta x. Remember, that's just change in y's over the change in x. Okay, number 4, then this rate of change that we calculated, this is the result we get from that is the average rate of change for the interval between the 2 points chosen. Okay, remember when we calculate that, again, it's important to understand that this is the average. Okay, now the most important step we need to get out of this is step number 5 when we interpret what our answer means. How does our answer help us in the problem? Like, what is the context of what we just found? Okay, and we'll talk about that more as we get deeper into these examples. Okay, so let's revisit that first example we kind of went through. Describe the rate of change between the years 2008 and 2011. Okay, so now our step 1 told us to identify the starting point. Our starting point would be 2008. Okay, step number 2 tells us to find the end point of the interval, and that would be 2011. Next, we need to calculate the rate of change. And remember, to calculate the rate of change, we do delta y over delta x. This is just the change, okay, or the difference between your y's and the difference between your x's. So one might say difference means subtract, so we're just going to minus the start from the end. So you can start with the y's because on top we're going to deal with the y's. So the first one I would do is, if I were to start, let's always just start with the start, and then our second one can be our ending point, or you can do it vice versa. You should get the same answer, but I'm going to start with my start point. So if I'm talking about my y's, which is over here, my start point would be 66. Okay, I'm going to subtract the end point, which would be 51. Those are my y's. Now I need to find the change in my x's. So again, go back to the start of my x, which would be 2008. I'm going to subtract the endpoint, which is 2011. Okay, 66 minus 51 would be 15, and 2008 minus 2011 is negative 3. Now, can we simplify this fraction? Well, 15 divided by negative 3 does simplify to negative 5. Okay, so now this result that we just got here is the average rate of change between the year 2008 and 2011. So the important step, so step number 5, is we need to interpret what this means. Interpret what that negative 5 means. So what that means is on average, each year, about 5 million, remember my Y's are in terms of millions, 5 million households have gotten rid of landlines and cell phones. So why did I say gotten rid of? Okay, remember it's a negative 5 years, so it's going down, it's decreasing. So that's why they have gotten rid of landlines. So on average, each year, about 5 million households have gotten rid of landlines and cell phones. That's what it means to interpret that. So let's try another example. Our next example, we are again given a table. So the table below represents a type of bacteria that doubles every 36 hours. A petri dish starts out with 12 of these bacteria. Okay, now it's telling us we need to calculate and interpret. That's important. We also need to interpret the average rate of change from x equals 2 to x equals 5. So this tells me that my start point is at x equals 2 and my end point is at x equals 5. So then let's calculate delta y over delta x, which is also just the change in y over the change in x. So the change in y is from 30 to 121. So again, just start with the start point, 30 minus your end point, which is 121, over my x values, which is 2 minus 5. So 30 minus 121 is 91, negative 91, excuse me, over negative 3. Now here, 91 over 3, does that simplify? Unfortunately, it does not, but we do know that these negatives are going to cancel each other out. So my simplified answer should be 91 over 3. This 91 over 3, remember, that's the average rate of change from x equals 2 to x equals 5. So now I need to interpret what that means. Remember, when we interpret what that means, I'm writing that sentence down. What does that mean? Well, that means on average, the bacteria is increasing by 91 every 3 days. So this rate of change, 91, is what it's increasing. Okay, that's my y, that's my output, and 3 was my input. So 3 is in terms of days. Thinking here, it's in terms of days. So every 3 days, the bacteria is increasing by 91. For our next example, we need to find the rate of change for the intervals from x equals 1 to x equals 3. So first thing, I should go over to my graph and kind of figure out where these points are. If I look at my x value of 1 and go up and make a point on my graph, right about there, that's going to be, I don't know exactly, so if I just kind of took a little bit of a guess, I would guess that's at 1 and let's say 550. Okay, and the next dot I have to find is at x equals 3. So if I draw that dot, again, I'm just guessing. My best guess would be 3 and 1,150. Okay, so now I need to find the rate of change for this interval from x is 1 all the way to x equals 3. So again, we're going to use that formula, change in y over change in x. So the change in y's then, if I do my start point, would be 550 minus 1,150 over 1 minus 3. So 550 minus 1,150 is a negative 600, and 1 minus 3 is a negative 2. So when I simplify that, I should get a positive 300. So my average rate of change from the x value of 1 to 3 is 300. So what this means is, on average, for every year, the investment in dollars is going up $300. So every year from 1 to 3, the investment in dollars is going up $300. So let's try then the interval x equals 3 to x equals 6. We don't quite have that 6 yet, so if I draw that 6 dot up here, it's a little bit off our graph. Again, I'm just going to guess that it's going to be 3,250. So now, again, we're going to use that formula, change in y over change in x. If I start at my start point of 3, I get 1,150. I'm going to subtract 3,250 because that's my endpoint. This is all over the change in y. So from 3 to 6, I'm using that subtraction again. Remember, because it's the change, it's the difference. Difference means subtraction. So 1,150 minus 3,250 is a negative 2,100, 2,100, and 3 minus 6 is a negative 3. So that then will simplify to a positive 700. So again, this means every year from the interval 3 to 6, this investment in dollars is increasing by $700. So my final question then is, which interval has a larger average rate of change? Looking at my two numbers, which number is bigger? Obviously, we see that 700 is bigger than 300. So to answer this, it's from the interval x equals 3 to x equals 6. That's going to give me that better or larger average rate of change. So we also got this third little sheet that's separate from your foldable. I just need you to fill these in, and we'll talk about this more as we get to class. So write down these notes so you have them when we get to class tomorrow. And then I thank you for taking good notes. I will see you when I see you.